Hi everyone, this is Dhanasigaran, Assistant Professor, Department of Electronics and Communication Engineering, KS Rangaswamy College of Technology. Today we're going to discuss about addressing modes of 8051. So these are the outlines of addressing modes of 8051: immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, in-text addressing mode, and implied addressing mode. So before we going to see about the addressing modes of 8051, we should know about the what is addressing mode. Addressing mode refers to a specific method that the microcontroller uses to access operands during the instruction execution. It refers how we specify the location of an operand that is required by an instruction. By using the addressing modes, we can specify the source and destination of data in different ways. So, based on that, we have the different types of addressing modes. How the operand of an instruction is specified. Uh, so, the types of addressing modes are immediate addressing mode, register addressing mode, register direct addressing mode, and register indirect addressing mode, in-text addressing mode, and implied addressing mode. So in this immediate addressing mode, the data is provided in the instruction itself. So the data is immediately moved to the register or a DPTR. So if you take the example of move a comma has 0AFH, that is the data is directly specified in the instruction itself, that is moved to the A. That is, this is called immediate addressing mode. The hash symbol indicate that the immediate addressing mode, and H indicate that the hexadecimal notification. And if you take the example of R3 comma hash 45, the value, the content, that is 45 is the data that is moved to R3. And for move DPTR comma hash FE00H, that is FE00H is the address that is moved to a data pointer, that is a DPTR. So here they immediately move to the DPTR. In register addressing mode, the source of our destination data should be present in a register, that is the register bank from R0 to R7. Here we have the example, that is move A comma R5. The content of the R5 will move to the accumulator, that is A. And the next instruction, that is move R2 comma hash 45. Here we have used R2, that is a register addressing mode. The value that is specified in the instruction itself, that is 45, will move to R2. In the last instruction, move R0 comma A. Here the accumulator, the value of the accumulator will be moved to R0 register. So here we these instruction we have used registers, that is R5, R2, R0. So this is called a register addressing mode. So we can use a register from R0 to R7 for moving a data from destination to source or source to destination. Next one is the direct addressing mode. In this direct addressing mode, source or destination address specified by 8-bit data in the instruction. Only the internal memory can be used in this mode. So here we have the examples. If you take move 80H R0, comma 80H comma R6. In this instruction, when you executed this instruction, you will get the data of R6, that is the content which is stored in the R6 will directly move to 80H. The 80H is the 8-bit address. So the content of R6 will move to 80H. So here we directly mention the address, that is 8-bit address. We have mentioned the instruction itself. The next instruction move R2 comma 40H. Again the 45H is also the 8-bit address. The content of 8-bit address, that is the value stored inside the 45H, that will be moved to R2. So the last instruction move R0 comma 05H. The content of the 05H, that is 05 is 8-bit address, and we have the content of 05H, that is the content will move to R0. And in the register indirect addressing mode, in this mode the source destination address given in the register. By using the register indirect addressing mode, the internal or external address can be accessed through the register indirect addressing mode. So as we said, the R0 to R7 register we have used in the last addressing mode, where in the register indirect addressing mode the R0, R1 and are used in 8-bit addresses, and DPTR is used for 16-bit address. So in the register indirect addressing mode, we have two examples I mentioned in the PPT, and that is move E5H at R0. So whenever we saw the indirect addressing mode, we can see the dot symbol. So it indicates register, that is indirect addressing mode. So indirectly the R0 content will move to a E5 address, and move at R1 comma 80H, that R1 is the external register. The value of the content stored in the 80H will move to indirectly to the R1. After execution, the content of 80H will move to R1. So this is the indexed addressing mode. In this indexed addressing mode, the source memory can be only accessed from the program memory only. The destination operand is always the A register. So whenever you use the indexed addressing mode, you can defaultly the accumulator will be the destination operand. So whatever your function you added in this, finally it will be stored in the accumulator. If you take the example of move CA comma at A plus PC, so in this the program counter value will be added with A, that will be stored in the accumulator. Again, if you see the move CA comma at A plus DPTR, the DPTR we have a address, and that will be added with the accumulator, and the address will be changed, that will be stored in the accumulator. That is a function of this instruction. And coming over to the implied addressing mode, there will be a single operand in the implied addressing mode. This type of instruction can work on a specific registers only, and this is also called as a register specific instruction. So if you take RLA, that means rotate left accumulator. So if you take accumulator, we'll have some content. That content will be converted into a binary. The binary will have a 8-bit capacity that will be rotated with the left. So it will be shifted with the left side. The position will be changed in the accumulator. Whenever the binary position will change, the data will be data also change. So if you take the example of 11110, final will be 0, the value will be the F and E. If you change the position, the value will be changed, so that will be stored in the accumulator. Whereas in the swap operation, the accumulator value will convert it into the binary, that 8-bit value. So here the MSB value and LSB value both are shifted each other, so that it value will be swapped. That's why we used implied addressing mode. And these are the advantage of addressing modes in 8051. So we have the improved code flexibility and efficient memory usage and versatile programming. We can use direct, indirect, and reduce instruction count. So these are the advantages of addressing modes. And thank you for watching.